Hey folks, welcome to our channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have 3x plus 1, the whole divided by 2x square minus 2x plus 3. So what we've been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down what our y is. So that's my y, integral of 3x plus 1, the whole divided by 2x square minus 2x plus 3 times dx. So I know that my y is not in a very simple format whose antiderivative I know from first principles. But then when I take a closer look at y, I see that I have a quadratic expression in the denominator and then I have a linear expression in the numerator. So the way we go about solving this problem is figure out a way where we can connect the quadratic expression with the linear expression in the numerator, right? How do we do that? I see that we have 2x square minus 2x plus 3, right? And d by dx of 2x square minus 2x plus 3 is nothing but 4x minus 2, right? Which is again a linear expression. So the best way to connect the denominator with the linear expression in the numerator is by expressing the numerator, which is 3x plus 1 in this case, in terms of the derivative of the denominator, which is the quadratic expression 2x square minus 2x plus 3. So the next couple of steps, that's what we're going to do. So let me write down the derivative of the quadratic expression first. My d by dx of 2x square minus 2x plus 3 is nothing but 4x minus 2, right? So now I have a 3x plus 1 in the numerator. So all that I got to do is express 3x plus 1 in terms of 4x minus 2. I repeat, express 3x plus 1 in terms of 4x minus 2. So the best way to do that is write my 3x plus 1 as a times 4x minus 2 plus say another constant b, right? Now you see both are linear expressions, your LHS and RHS. And what I have on my LHS is a 3x plus 1, and what I have in my RHS is a times 4x minus 2 plus b, right? Which is nothing but a 4a times x minus 2a plus b, right? Now the coefficient of x on my RHS is 4a and the coefficient of x on my LHS is 3. So let's write down that. Now, since I'm equating these two, what it means is my 4a equals 3, which means my a equals 3 by 4, right? That's step number one. And now we'll have to figure out what our b is. Now I have a constant term plus 1 on the LHS, and then I have a minus 2a plus b, which is again a constant term on my RHS. So I equate them, minus 2a plus b equals 1, right? And how do we go about solving for b from here on? I know my a is 3 by 4. And when I substitute 3 by 4 in place of a, what do I get? I get my b equals 5 by 2, right? Now I'll go back to my y and I'm going to rewrite my numerator in terms of the derivative of the denominator quadratic expression, right? So what happens to the numerator in this case? My 3x plus 1 becomes a times 4x minus 2 plus b, right? And then my denominator remains as it is for now. Now, what did I work out just now? I worked out my A and B, right? So my A is 3 by 4, okay? And what is my B? My B is 5 by 2. So I just go ahead and substitute my A and B in this expression. Now, my Y is nothing but integral of 3 by 4 times 4x minus 2 plus 5 by 2, the whole divided by 2x square minus 2x plus 3 times dx, right? Now the way to go about solving this problem from here on is to decompose your y, apply the sum rule of integrals to solve this problem, right? So let's go ahead and do that. Now, when I'm doing the decomposition, you'll have to remember that I expressed my numerator linear expression in terms of the derivative of the quadratic expression in the denominator, right? So the way we decompose this is treat 3 by 4 times 4x minus 2 together, and then your 5 by 2 separately, right? So when I express my y using the sum rule of integral, what do I get? So now the way I'm going to solve this problem is I'm going to treat the first integral, which is integral of 4x minus 1 the whole divided by 2x square minus 2x plus 3 as y1. And the second integral, which is integral of dx by 2x square minus 2x plus 3 as y2, right? So what happens to my y? My y is nothing but 3 by 4 y1 plus 5 by 2 y2, okay? Now we will solve for y1 and y2 separately, right? I'm going to treat y1 now. Let's call it part 1. And my y1 is, let me copy my y1. So this is my y1, and I notice that I have a term integral of f dashed of x divided by f of x times dx, right? And why is it f dashed of x divided by f of x times dx? Because d by dx of 2x square minus 2x plus 3 is nothing but 4x minus 2, right? And this is not very complicated. My answer to this problem is log of mod of 2x square minus 2x plus 3 plus your constant c, right? You can solve this by the method of substitution. Just make the substitution t equals 2x square minus 2x plus 3, and then express your y1 in terms of t and solve the problem. It's not very complicated, and that's the way to go about solving this problem, while I have directly put down the answer here. Right now, let me go to part 2, and my part 2 has got a bit of work, but it's not very new to us. We've solved similar problems in the past. So let me write down my y2, which is my part 2. My y2 is nothing but integral of dx by 2x square minus 2x plus 3, right? So I have a plain quadratic expression in the denominator, right? And the way we go about solving these problems is express the quadratic expression in terms of x plus or minus a the whole square plus or minus b square, right? So that's what we're going to do. So what I'm going to do is I'm going to park y2 aside, just pick up the quadratic expression, which is your 2x square minus 2x plus 3. So let me pull out the 2 first. And what do I get? I get 2 times my entire expression becomes x square minus x plus a 3 by 2, right? And this can further be rewritten as, watch me closely, because my first part I don't really need to worry about, and my second part has got a minus x, right? And how am I going to write this? Minus 2 times 1 by 2, right? And I hope you folks are with me and you do understand why am I doing this, right? It doesn't change the expression in any way, because a 2 into 1 by 2 is equal to a 1. So I rewrite my minus x as minus of 2 times half times x, right? And then I have a 3 by 2, right? Now take a look at this. We all know that a minus b the whole square equals a square plus b square minus 2ab, right? So I notice that I have an x squared term, and then I have a 2 times half times x, right? And let's do a simple thing out here without changing the expression, right? I'm going to add a plus 1 by 4, and I'm going to subtract a plus 1 by 4, right? And my 3 by 2 term, which is a constant, remains. Now let's try and combine the first three terms using the a minus b whole square formula. Let me highlight it in yellow for you folks. Now my x squared minus 2 times half x plus 1 by 4. What is that? It's nothing but an x minus half the whole square, right? And what happens to this part of the expression, which is nothing but a 3 by 2 minus 1 by 4. And let me highlight that in probably a different color, say green. That's again a constant, which is 1.5 minus 0.25, right? Which is your 1.25. So I go to the next step. I rewrite this in the manner x plus or minus a the whole square plus or minus b square. My 2 remains as it is, and the yellow portion inside the bracket is nothing but an x minus 1 by 2 the whole square. And then the green portion, which is a 3 by 2 minus 1 by 4, right? What is that? It's nothing but a 5 by 4, right? So we have the quadratic expression re-expressed as 2 times x minus half the whole square plus 5 by 4. And if I were to draw a parallel to x plus or minus a the whole square plus or minus b square, then my b square equals 5 by 4, which means my b equals root of 5 by 2, right? So the quadratic expression becomes 2 times x minus half the whole square plus root 5 by 2 the whole square, right? Now let me go back to my y2, and what happens to my y2 now is I'm going to rewrite my y2 in the format what we just arrived at for the quadratic expression, right? So what happens here is now I have my dx as it is, and then my quadratic expression has got 2 as a common factor, right? I'm referring to this particular 2. Let me call it using, say, a turquoise color. I can pull this 2 out of the integral because it's a constant. So what happens here is I get a 1 by 2, and then my remaining portion of the expression is nothing but an x minus half the whole square plus root 5 by 2 the whole square, right? So this is what I get. So this is nothing but an equation of the type integral of dx by x square plus a square, right? And how do I bring it to that particular format? I make a simple substitution, t equals x minus half, right? And what happens to my dt? My dt becomes equals dx, right? And then I go back to my y2. I try and put back everything in terms of t, right? So I get a half times your dx is dt and your x minus half is t. So my first part of the denominator becomes a t square, and then my second part remains as it is, and therefore what you have right now is an integral of the type dx by x square plus a square, just that in place of x you have a t. And the way to solve this is not very complicated. We use trigonometric substitution to solve this. I know that some other books will insist on you to remember this as a formula, but then I'm going to solve it by making the trigonometric substitution out here very quickly, because there are too many formulas to remember. Then and you're likely to make a mistake when you blindly apply the formula when you solve these problems, right? In case you make a small error, you'll get the final answer completely wrong. So it's always better to make the corresponding substitution and then solve this problem. That's my way. But if your memory is like too good and if you're able to remember the formula, then well and good, right? So what I'm going to do here is I'm going to connect it with one of the basic trigonometric identities that I know, right? And I know that my sine square theta plus cos square theta equals 1, and my secant square theta minus tan square theta equal to 1, right? And I think a better substitution that would work here is t equals root 5 by 2 tan theta. my dt becomes equal to root 5 by 2 secant square theta d theta, something that I expect all of you to know from the lessons of differential calculus and first principles, right? So that's my dt. Now I go back to my y2 and allow me to do this on the same line. Now what I do is I try and express everything in terms of theta, right? So what happens to my numerator is my dt becomes root 5 by 2 secant square theta d theta. So I just copy it as it is. And then my denominator, which is where I want you to watch this closely, what happens is it becomes a root 5 by 2 the whole square plus root 5 by 2 the whole square tan square theta, which is nothing but a root 5 by 2 whole square secant square theta, right? Why is that? Because your 1 plus tan square theta is nothing but a secant square theta, right? So I have root 5 by 2 secant square theta d theta in my numerator, and in my denominator I have a root 5 by 2 the whole square secant square theta. So all that I can do is cancel out the secant square theta and then cancel out the one of the root 5 by 2 in the denominator with the root 5 by 2 in the numerator, right? So what am I left with? So I'll be left with 1 by root 5 times integral of d theta, right? And what is your integral of d theta? Is nothing but theta, right? So all that I get out here is 1 by root 5 times theta plus my constant c. You know that I cannot leave everything in terms of theta. I'll have to put it back in terms of x, right? So what are those two substitutions that we did? The first substitution that we did was t equals x minus 2. So let me highlight that. And the most recent substitution that we did was t equals root 5 by 2 tan theta, right? So what I'll do now is replace my theta in terms of t and then go ahead and replace my t in terms of x, right? So my theta is nothing but tan inverse of 2t by root 5, right? And then my t equals x minus half, right? So, and if I take the 2 inside, all that I will get is a 2x minus 1, right? So you have your y2 now, 1 by root 5 times tan inverse of 2x minus 1 divided by root 5 plus c. And then you also have your y1, right? So let me highlight my y1 and y2. My y1 is this particular log expression. And let me highlight it and say green, right? And what is my y2? My y2 is nothing but a 1 by root 5 times tan inverse of 2x minus 1 divided by root 5. Let me highlight that as well in green, right? So now we go back to our y, and I know that we expressed our y in terms of y1 and y2. So my y is nothing but 3 by 4 times y1, right? That's the first part of your y. So so what happens is my first part becomes a 3 by 4 times log of mod of 2x square minus 2x plus 3. And then I come to my second part, which is a 5 by 2 times y2, right? And what is my y2? We just worked that out now. 1 by root 5 times tan inverse of 2x minus 1 divided by root 5, right? So I'm going to copy paste that as well. So my first part of the expression, I don't think I can do any further simplification. The second part of the expression, I have a 5 by 2 times 1 by root 5. So what is a 5 by root 5 is nothing but a root 5, right? So I can remove the root 5 in the denominator and I can express this as root 5 by 2 times the tan inverse expression, right? So there we are. Any further simplification possible? I don't think so. So we have arrived at our final answer. Let me highlight my final answer in pink. Yeah, 3 by 4 times log of mod of 2x square minus 2x plus 3 plus root 5 by 2 times tan inverse of 2x minus 1 divided by root 5 plus c. Right? I hope you found my content useful. Please do subscribe to my channel and support. Thank you.